Hello everyone, welcome to the lecture series, that is lecture 2. So today what we are going to do is we are going to evaluate, that is we are going to see the concept of, that is evaluation by change of integration, right? We shall see this concept, evaluation by change of integration, that is change of order of integration, right? So what does this mean? Now given limits, then that is when the limits of integrations are variables in a double integral, a change in the order of integration requires a change in the limit. So what, there is change in the order of integration requires what, change in the limit of integration. Now let us see its working rule, right? So case 1, now any double integral, that is from dy dx to dx dy. Suppose the given double integral is given in the form of, that is integral. So usually in the previous example what you have done, you have solved, see here, examples like this. So that is the integrals solved over the limiting values, that is sum y is equal to f1 of x, and this is y is equal to f2 of x, and see the order which we followed is this, right? First we evaluated this inner integral, and then later we have evaluated it for, that is outer integral, that is with respect to x, right? Fine. Now this, okay, so this is my first step 1, that is let me consider this equation first, and then I need to convert this, change the order from dy dx to dx dy, right? So this type of integral is given, and then you need to convert it to, that is dx dy. Now the next thing is the region R is bounded by the curves. So you need to locate the curve, that is it is bounded by the curve that is at x equal to a and x equal to b. Similarly y is equal to f1 of x and y is equal to f2 of x, that is lower and upper limit, lower and upper limit. Then find the point of intersection, right? So this is your step 1, this is your step 2, and this is your step 3. Now what you need to do is you need to draw a rough sketch, right? So draw a rough sketch of the region of the integration R and check whether it is correct or wrong first, and by drawing a vertical strip. So when the concept is for dy dx, right? Fine, at that time you need to draw what, vertical strips, right? Now step 4, what you need to do is initially you will take, that is vertical strip, that is top to bottom or bottom to top, right? In order to reverse the order, now you need to reverse the order of integration, we draw horizontal strip. So what do we do is we draw horizontal strip cutting through the region R, and write down the given integral as I is equal to integral from, that is f is a function which contains x and y variable dx dy. Now here, since after doing, that is reversing the order of integration and taking horizontal strip, we have the new limits, and the new limits is x limits will be, x is a function of g1 of y to x is equal to g2 of y, and y limits will be y is equal to c to y is equal to d. Therefore by changing the order of integration, we have, that is I is equal to integration of c to d, integration of g1 of y, g2 of y, f is a function of xy, dx dy. So see this function, so this is nothing but x equal to g1 of y, x equal to g2 of y, and this is nothing but y is equal to c to d, right? Fine, c to d, and then you evaluate this integral first. This is how we change the order of integration, and then the outer of that is the outer integral later. Similarly, case 2 will be, that is I need to change the order, that is from dx dy to dy dx, right? Now this, what I'll do is, here the concept is same, and here this steps are also the same. Here what you do, you take horizontal strips. First you note down the limits, draw a rough sketch, and then draw a horizontal strip first, and then when you change the order of integration, you take vertical strip, right, and then solve it, right? So before moving on to the example, let me show you few geometrical so these are some important curves along with equation, right? So you should know this, some important curves along with equation. So a straight line, x equal to 0 and y is equal to 0 are respectively the equation of y and x. So here x equal to 0 and y is equal to 0. So x is at a distance c1, so this is x is at a distance c1, and y is at a distance c2, this particular line. So y is okay, are respectively equations of line parallel to y-axis and parallel to x-axis. Now see here, y is equal to mx plus c is a straight line passing through the origin, and particularly y is equal to x is a straight line passing through the origin subtending an angle 45 with x-axis. So this is an equation of a straight line, and this is y is equal to x, and this is y is equal to mx, and m is nothing but the slope, right? Now this equation is the slope intercept form. So the slope is intercepted between x and y over the coordinate, that is a comma 0 and 0 comma a. So it is always given by, that is x by a plus y by b is equal to 1. This is a unit, that is circle equation with center as origin and radius a, right? Fine. So this is a parabola, right? Y square is equal to ks, and it is symmetrical about x-axis. So it is symmetric about x-axis. So this y square is equal to ks, and it is symmetric. If you fold this from x-axis, it is symmetric. Similarly, x square is equal to cy is symmetrical about y-axis, right? And these are later cases that finding area, volume, surface area. So just have a glance. This everything I have given you in my notes, so you can also go through the notes. See, over the region R in, this is in Cartesian form. Right now we are dealing with the concept of, that is double integral, and if the function is in terms of, f is a function in terms of r and theta, so area of region R in the polar form, right? So let us see how this problem works. So the concept is clear, right? So we are dealing with the concept of what? Evaluation by, that is change of order of integration, right? Now, yeah, so this is my first example. Example 1, change order of integration and hence evaluate, that is 0 to a, and hence evaluate the given function x divided by x square plus y square dx dy, right? Now this is y, and the limiting values are, that is y to a and 0 to a. So solution, let I is equal to integration from, that is integration of the function x divided by x square plus y square dx dy and y is equal to a, and sorry, the limiting values are y to a and 0 to a. Now the limits of this integration, or this is my region R or the area. Okay, first thing is, what you do, you always draw a rough sketch, right? Fine. So the order here, it is fine. So this is in terms of x is equal to, right? The marker is not working, so okay, please kindly adjust. And this is y is equal to, so this order is correct. So I need to change this dx dy to what? So I think it is the second method, dx dy to, it is, I need to change it to, that is dy dx, right? Yeah. Now the limits of integration are, see, y is, first you write this box, right? Okay, then y is from 0, right, to a, right? How it is, like, okay, so here it is y is equal to, and x is ranging from what limits? X equal to y and x equal to a, right? Now first thing is, you need to draw a rough sketch. Right, but here, see here, initially what you need to take, that is horizontal strip. This is my case 2. Please go through the working. Okay, so see here, so x equal to y or y is equal to x, what is the geometrical interpretation of this? That is, it is a straight line. So this you are going to take like this, yeah, fine. And x equal to a, what do you mean by x equal to a? That is, x is at a distance a, so this is it, right, which is parallel. So x is from, that is y to x equal to a, and what is happening to y range? It is y is equal to 0 to y is equal to a. So y is equal to 0 to y is equal to a. Okay, when you evaluate this thing, like, see, when you substitute y is equal to 0, so what will happen to x? It will turn out to be 0. And when you substitute y is equal to a, so x equal to a, therefore the point of intersection will be a comma a. Therefore the new limits will be, this x will be converted into what? It will be converted into y, right? Now here what you need to do is, the next step, or else here only in this particular graph only you can draw a vertical strip. This is for your understanding purpose. See, now what I do is, to have my new limits, I draw this. First it is horizontal strip, and now I take it as, that is vertical strip. So what is happening to y? Now I have to change it to x to y. So what is happening to y? Y is ranging from, this is 0, any value on this x-axis turns out to be 0. So 0 to what? So it is still here till the maximum value, that is a, this coordinate, right? Right. So it is, y is ranging from 0 to a. Then what is happening to x? X is ranging from x equal to 0 to a. Therefore the new limits will be, so what is happening? So this is, so this was in terms of x equal to y. Now it is y is equal to, y is ranging from, that is 0 to a, and x is ranging from x equal to 0 to a. And the rest of the things which we have evaluated in the previous examples, right, which I have given you in my lecture 1, right, how to evaluate this. So once if you do this, the later part is all evaluation, fine. Now so x is ranging from 0 to a, so this x, so you need to, so this is y, so I should take dy first, that is the order, right? If I differentiate it, integrate it with respect to y, so x is constant, so x I take constant outside, so 1 divided by x square plus y square will turn out to be 1 divided by x tan inverse of y by x over the limit y is equal to 0 to, that is a. Okay, fine. So here I think, yeah, I have spotted a not mistake here in writing. Sorry. Yes. See, what is the value of y? It is ranging from, that is y is equal to 0 to what? So it is y is equal to x not a comma a, right? So y is equal to x, right? So here it turns out to be y is equal to, here it is x. Please make this possible correction. Yes, please make this correction. Yeah, so y is ranging from, that is y is equal to 0 to x, and what is happening to x? X is ranging from, that is 0 to, that is x equal to a. Now, yeah, since so x divided by 1 by x tan inverse of y by x, y is equal to 0 to x first. So if I substitute the value of x here, this x gets cancelled, and x it becomes tan inverse of x, and this becomes tan inverse of 0. So tan inverse of 1, it is pi by 4 into dx, right? So evaluating over the integral, that is x equal to 0 to a, so pi by 4, which is constant, and x evaluated, and this gives you your answer. Easy? Fine. Okay, fine. Now let us have the next question and see it. The question is, yeah, the question is, that is integrate x by dy dx over the limits, that is x to square root of x 0 to y. Now let me consider this. Let I is equal to the given integral x by dy by dx x to square root of x 0 to y. Now let me have this, so this is in terms of y is equal to, and this is in terms of x equal to, so x and dy. Yeah, so what I'll do is, I will first see the limits of integration are x equal to, that is here it is 0 to 1, and y is from x to, that is square root of x square. Now see here, y is equal to x is nothing but, it is a straight line, right? And y is equal to, that is y square is equal to x is a curve, right? Now I need to find this point of intersection too, and x is ranging from, that is 0 to 1. So since this is dy dx, so what I do is, I take the horizontal strip first, right? Now y is equal to x and y is equal to square root of x, and x equal to y, x equal to y square. So when I evaluate these two equations, what will happen? See here, when I substitute x equal to 0, so y turns out to be 0, and when I substitute x equal to, that is 1, so y turns out to be, that is 1. So this is, so the value of this point of intersection will be 1 comma 1. Now the same figure I retain it, and this time it is, therefore the new limits will be, so what I'll do is, I'll draw the same figure, or else I will draw it here. Now we need to go horizontally, since it is y, you need to change in terms of x, right? So x will be ranging from, that is C, that is x equal to, see, this is what, this curve is y square, so x will be from that is x equal to y square, either you in this, and x equal to y. So this point and this curve, right? Fine. Yes. And y is ranging from what? Y is from here on the x-axis, it is 0 and till 1, this point of intersection, right? From here to here, and for x it is here. Now you have changed the limit, therefore the new integral will be I is equal to integration from y is equal to 0 to 1 and x equal to y square to y. It is not y to y square, it is y square to y, because I am taking this particular value, right? So xy dy dx, and the rest is so since it is given, so here it will be evaluated with respect to dx first. So integration of x, this y is constant, x square divided by 2 square over the integral y square by y, that is limiting points, dy. So this is y in the bracket y square minus y square, again integrating it with respect to this constant, that is x equal to 0 to 1, and sorry, it is y is equal to 0 to 1 dy. Finally, after evaluating, you get 1 by 24. Is it right? At any instant, if you have any doubt, you can call me up or contact me, right? Yes. So let us move on to the problem. Next problem. Yeah. So this time the given function is e raised to minus y divided by y dy dx, and the limiting points over the given region of integration is x to infinity and 0 to infinity. Solution, that I is equal to, write the given thing, that is that over the double integral e raised to minus y by y, that is your function dy dx. So the limits of integration are, first thing is you need to draw a rough sketch. So draw a coordinate x, y. Fine. See, y is equal to x. What is y is equal to x? Y is equal to x is a straight line. So first thing is you draw a straight line. Fine. And next, it is infinity. So, and this given equation is, that is dy dx, and it is of the form dy, that is y is equal to. So first thing is, what you are going to do, you are going to draw, that is vertical strip first. This is directly I have given, right? Only one sketch I have done. So what you do is, so here it is dy dx, so all the time you need to draw this. So y is ranging from, that is y is equal to x to infinity, right? Okay, and x is from 0 to infinity. So obviously x is equal to 0 to infinity. Now the limits of integration will be, this is the limit of integration, that is y is equal to x to y is equal to infinity, and x is from 0 to x is equal to infinity. Therefore the new limits will be, now what I'll do is, I have to change this y in terms of x, so the new limits will be, and x in terms of y. Therefore y is equal to 0, x equal to 0 to x equal to y, this particular line, this line, right? And y will be ranging from, that is y is equal to 0 from here to here, so it is infinity. Fine. So y is equal to 0 to infinity, right? Now here, therefore the given integral, that is we have changed the order. Fine. So we have changed the order, right? Fine. So the given new limits will be of the form x equal to 0 to y, y is equal to 0 to infinity, and this given function. Since it is x equal to 0, so I will evaluate this integral first, right? So integration from, that is e raised to y, so integrating it with respect to x, so it is 1, so x over 0 to y dy, right? Fine. And then integration y is equal to 0 to infinity e raised to minus y by y divided by this y gets cancelled, so y is equal to 0 to infinity e raised to minus y and dy. So integration of e raised to minus y turns out to be minus 1, minus outside, and e raised to minus y over the limit e raised to, that is, infinity. So this upper limit will be e raised to, so that I can write it as, it is 1 divided by e raised to infinity minus this, anything power infinity, you can write it as 1, right? So this is 1 minus this is 0, right? And this is minus outside this sign, so this will be plus 1, right? Getting? So this part, upper limit minus lower limit, right? Okay. Okay, now next problem is, let me see what is this next problem. So integral over, that is, the given function is x e power minus x square by y d by dx, and this is 0 to x. So when it is dy dx, okay, and the limiting value, other limiting value is 0 to infinity. So this is your given region R or A, you can say, fine. And now here, so this is nothing but, see here it is a variable x, so it is of the form y is equal to g2 of x, and here it is y is equal to g2 of 1. So this is in terms of, sorry, this is y, this is x equals, right? Fine. So now first thing is, I will write the given equation and draw a rough sketch. So y is equal to 0 to y is equal to x. So y is equal to x is nothing but what? It is, that is your straight line, okay? And since it is dy dx, first thing is I need to draw vertical strip first, and x is ranging from 0 to infinity, so x is ranging from, that is, 0 to infinity, right? This side. Now I need to change this order. So my given limits of integration, first write this limit of integration with respect to its rough sketch. Now since it was dy dx, it was horizontal, sorry, vertical. You have taken initially, that is, vertical strip. Now I will convert it into horizontal strip, which is already there, right? Okay. Now new limits will be, so this is, see here, now this y will be changing. I need to change this course to y. So x will be from x equal to y, from here, from this position to what? To infinity. So x will be ranging from, that is, y to infinity, and I need to change this course also, x in terms of y. So what is happening to y? Y will be from y is equal to 0 to, see this points you need to take. So y is equal to 0 to infinity it is, right? This might take any value, right? Here. Okay. Now, yes. So after after the change of integration, you have the new limits, that is x equal x equal to y to infinity and y is equal to 0 to infinity. In few textbooks or in some notes, you might also see that this description is given in words, that is, x ranges from, y ranges from, right? So it's better to write it in this tabular manner, so it is easily understood. You show us the you write this limits and the given limits with respect to this rough sketch, right? So all the thing is, you should know all the conic section formula, standard figure equation, slope intercept form, equation of a straight line, which I have already showed you, right? Okay. Now when so what I do is, to evaluate this integral, to not to make it much complicated, I substitute, that is, x square x square by y is equal to t. If I differentiate this with respect to dx, right, so this turns out to be 2x by y dx equal to dt, or x dx equal to y dt by 2. Now see, I need to change the limit, right? When, see here, when x equal to y, right, so this turns out to be y square here, right? So what will happen to t? This, when x equal to y, this turns out to be y square by y. So this y and this y get cancelled. So what is happening to t? T is equal to, that is y. Fine. And when x is equal to infinity, therefore obviously t is equal to infinity. So even I am changing what? I am changing this limit, right? So t is equal to y and t is equal to infinity. Okay, and this x since you have changed, so x dx I can write it as y dt by 2. So this is y by 2 dt. So after changing this, you have got this, and t is nothing but what? It is x square by y, and which I have written as minus t. Okay, now what you need to do is again the same. So it is in terms of t, you have to follow the pattern. I will solve this integral first, integrating it with respect to t, right? Fine. And now if I integrate this with t, right, so this turns out to be y by 2 minus e raised to minus t over the limit t is equal to y to infinity into dy. So this 1 by 2 I will take it outside. So this turns out to be y e raised to minus y. Fine. Because e power t, I can write it as 1 divided by e raised to t. So upper limit 1 divided by e raised to infinity, it is 0, and e raised to, this turns out to be e raised to minus y. Fine. In place of t you are substituting, that is minus y, and this minus and the other minus turns out to be plus, right? Upper limit minus lower limit, this minus sign is still outside and it gets multiplied inside and it becomes plus, and so is this y e raised to y. Now 1 by 2 integration of 0 to infinity y e raised to y. So you will use Euler rule or this di method, right? Fine. So what you do is, so write over this particular polynomial first, that is y e raised to minus y. Okay, now what is differentiation of y? It is 1. What is differentiation of 1? It is 0. What is integration of e raised to minus y? It is minus e raised to minus y, and integration of minus e raised to minus y, it is e raised to minus y. Now I take this cross arrows here like this, and I take cross arrows here like this, and from the left hand side I will write plus minus plus. Whatever is the value here, do not worry, always have the habit of writing plus minus plus. Then see here, y into minus e raised to y, which I have written here. Okay, then minus I have written e raised to minus y, or else you can use Leibniz rule to evaluate this. So over the integral 0 to infinity. So this again, if you take this cross, then again it is e raised to minus y. So I need not write this because it is 0, right? Yeah. So after substituting the value, that is 1 by 2 upper limit, that is this obviously turns out to be 0, upper limit minus, okay, minus 0. If I substitute here, it turns out to be 0. If I substitute here, it turns out to be 1. So this and this, again it turns out to be minus plus, and this is your answer, that is 1 by 2. Fine. Okay, now let us have this example. Fine. And yeah, see this example. So double integral dy dx log of y e raised to x, e raised to, that is e raised to x and e, and 0 to 1, right? So this is in terms of x, so I can take this as that is this is y is equal to, and this is x equal to, right? Yeah, now the limit of, I need to draw a rough sketch. So y is equal to e raised to x. See, y is equal to e raised to x is always a graph, yeah, which I have already studied in your plus to plus. It will be of this particular form, right? Exponential function, right? And y is equal to e, so it will be at some distance, right? So y is at a distance a, y is at a distance of 2, 3, so vertically, right? So, and the value of e, always you know that it lies between 2 and 3, right? So this is the given, yeah, y is equal to e raised to x and y is equal to e. Now, so here, so x is ranging from 0 to 1. So what is happening to x? So x is from, that is 0 to 1, fine. Yeah, now this is since it is y is equal to, so dy dx, so dy dx you have vertical strip first, right? This is what I have taken first. Now to convert it into new limits, so what I'll do, I will draw the vertical strip, fine. So vertical strip, now what will happen to this y? It will be converted to x. So what is the value of x? X is ranging from what, right? So x is ranging from, that is x equal to 0, 0 to what? X equal to, so this curve I need to take, right? So this curve is y is equal to e raised to x, that I can write it in the form of x equal to log y. So let me show this for you, right? See here, this is a definition of logarithm, right? Okay, this is definition of your logarithmic. Okay, so b raised to x equal to y can be written as, that is in logarithmic form, it can be written as log y to the base b equal to x. Similarly, it is e raised to x equal to y, right? And this turns out to be e raised to x, so it will be e raised to x equal to y. So that can be written as log of y is equal to x and to the base e, right? And since one of the property, okay, so this is how it goes, right? So this y is equal to e raised to x equal to y, okay, sorry, I take my words back, it is e raised to x equal to y, so I can write it as x equal to log y. So the new limits will be, see here, x is from 0 to, that is if I draw this horizontal strip, so x will be ranging from 0 to, that is x equal to log y. Now what will happen to y? So obviously y will be ranging from, that is y is at a distance, right? So y is from, y is equal to 1, right, to what? Y is equal to, that is e, getting, here it is at a distance e, right? And that is the thing, you should always have the habit of drawing a rough sketch, fine. Okay, now you might ask me, sir, why this is 1? See here, when you substitute x equal to 0, so this turns out to be y is equal to 1, yeah. So y is ranging from, that is y is equal to 1 to y is equal to e. Now when I evaluate this, now we are in terms of x, first I will integrate it with respect to, that is log y, yeah, log y, right? So this will be of the form, this will be now y is equal to e raised to x and e. So I'll integrate this first. So integrating it with respect to y. No, sorry, I take my words. So this was your integral, earlier integral, this is your question, and when from new limits I have changed y to x, so this will be of the form that is x equal to, so I will integrate this first with respect to dx. So this turns out to be x log y over the limit that is 0 to log y, right? And after evaluating it, this is log y upper limit turns out to be log y, this gets cancelled, 1 into dy over that is 1 to e, that is limiting values. Then if I integrate this with respect to y, so it will be y 1 by e, which is equal to upper limit minus that is lower limit. So your answer is e minus y. Getting? Yes. Okay, fine. Now let us see another example. So see here. So this is a given function. So function is 1 obviously, so d by dx, and the given limiting points are x square divided by 4a over and 2 square root of ax 0 to 4a. So let me write this integral first. So the limits of integration are, or the region of integration is, this is the region, right? Now what you need to do is, this is here, this is in terms of y is equal to, and this is x equal to. See here. So first thing is you need to draw a rough sketch, right? And yeah, so here the limiting values are x square divided by 4a, 2 square root of ax 0 to 4a, right? So this is in terms of y is equal to, so I can write this as y is equal to x square divided by 4a, y is equal to 2 square root of ax. Now see here, this y, this 4a, I will take it here, right? So this is x square is equal to 4ay. So this x square is equal to 4ay is a parabola opening upwards, right? This, right? And the next thing is that is y square, right? This, if I square this, this turns out to be square, this turns out to be 4, this turns out to be 4ax. So this is a parabola opening towards right, right? Fine. So this is how we draw a rough sketch, and obviously x equal to 0 to x equal to that is 4a, right? So what is happening to x? That is at a distance 4a, you can take it. Okay, now the point of intersection here, obviously it will be 4a comma 4a, that is on evaluating this particular parabolas, that is the intersection of points are 0 comma 0 and 4 comma a. Since it is in terms of y, so it is dy dx, you need to change the order into dx dy, and here it is dy dx. So first thing is you have taken a vertical strip, now you have to consider horizontal strip. Now the change of integral will be, see here, I need to change this x in terms of, that is y in terms of x. So x is in this equation, right? This equation, how can you write in terms of x? So what is this? X is equal to y square divided by 4a. So y square divided by 4a, this, right? 2. So it is already here in terms of x, so you need to that is you need to write this in terms of x. So this turns out to be x square is equal to, so that is x, take the square root sign this side, and that it is 2 square root of ay, right? And the limiting values will be x equal to 2 to square root of ay. And then what is happening to this vertical strip? Vertical strip will be, that is y is equal to 0, that is from here, okay, the constant value till y is equal to 4a, right? So since you have this new limits and there is a change in the order, now it has become dx dy. Finally when you evaluate this evaluation part, okay, so integration of 1 is x, y square divided by 4a, 2 square root of ay. So upper limit is this is upper limit, this is lower limit, fine, dy. Then again when you evaluate this, fine, so you have y 3 by 2 divided by 3 by 2, taking this constant outside, over the limit 0 to 4a, minus again this particular thing. So I need to differentiate this with respect to y. So this square root of y and this 2 I will take it outside, so it becomes y power 1 by 2. So integration of 1 by 2, it turns out to be 1 by 2 plus 1, 3 by 2 by 3 by 2, minus y square is y cube by 3. Finally when you evaluate, you get this answer, right? Okay, yeah. Okay, now this problem I hope you do it for homework, and it is very simple, fine. You can just have a observation. So these are the limiting values, right? This is a rough sketch. This is the new limit what we have done. So it is dy dx first. So vertical strip I have taken first. So this is with respect to vertical strip, right? Okay, now this, see here, this is y is equal to square root of ax. So this becomes y square is equal to ax. Y square is equal to ax is this parabola, right? And y is equal to a, x equal to a. Now many of the students get confused which is the area region bounded by the curve, like, so here see here, y is ranging from what? So it is vertical strip. Y is from a to, that is, sorry, y is from square root of a square, so this point of the curve, and till a, so it is this region, right? And x equal to 0 to a. Now the new limiting values is, see here, x is from 0 to this curve, you need to convert in terms of, that is x. So x here itself, so it becomes y square divided by a. And what will happen to y? It will be, that is 0. See here, from 0, see y is ranging from this value till the maximum value, that is 0 to a. And after evaluating this, see here, this here the given function is y power 4 minus a square x square. I will write this y power 4 as y square the whole square minus ax square, so which will be very useful for me to evaluate. So y square I will take outside, I will evaluate. Now it has changed its course to, that is order to dx dy. So this turns out to be sine inverse of ax by y, and over the limit 0 to y square by a dy, right? So here it is, okay, here it turns out to be pi by 2, right? Yes, y square divided by sine inverse of pi by 2, and okay, so this sine inverse of ax by over this evaluation will give you pi by 2 over the integral 0 to a y square dy, which is equal to pi by 2, that is y cube divided by 3, and 0 to 4. After evaluating this, you get this particular answer, right? Okay, fine. Now this is an interesting problem, so please pay attention to this problem first, right? So this is x squared 2 minus x and 0 to 1 xy dy dx. So it will be in terms of y is equal to, right? First thing is you need to draw this graph, right? So now the limit of integration are, so y is equal to x square to y is equal to 2 minus x, and x equal to 0 to x equal to 1. Now see, y is equal to x square is this particular graph, right? And y is equal to 2 minus x. See, this y is equal to 2 minus x, I have shown you, yeah, I will do it for you. So y is equal to 2 minus x. So if I take this x, it becomes x plus y, that is x to the left hand side, equal to 2, right? And here if I divide it by 2, so it becomes x divided by 2 plus y divided by 2 equal to 1, that is slope intercept form. So x is at a distance 2 and y is at a distance 2, right? So here it is, this is the graph, right? And this is the point of intersection, that is okay. Now fine, y is equal to x square and x plus y is equal to 2. Then see, on equating 1 and 2 we have, so this is quadratic equation, so y is equal to x square. So if I take this in place of y, if I substitute x square, so it becomes x square plus x minus 2, so x equal to 1 and x equal to minus 2. This minus 2 I won't include it, okay. From 1 and 2, because I do not have a common region of intersection, right? Therefore from 1 and 2, y is equal to x square or y is equal to 2 minus x. So what will be the value of y? See, when you substitute value of x as 1, here you have y is equal to, that is 1, and when you substitute x equal to, that is y is equal to 2 minus x, if you substitute this particular value you get, that is 4. You have two values, right? Sorry, I take my word back, this is the point. So x equal to minus 2 you need to substitute here, so square it becomes, right? So x is equal to, sorry, if you take this x equal to minus 2 here, it becomes 4, because here it is bounded. Since the region now is bounded by x equal to 0 and x equal to 1, and the point minus 2, 4 is not, it is not of consideration, that is the reason I have not taken here. And further, y is equal to x square is a parabola symmetric about y-axis, and y is equal to this. Okay, this is what I was telling you about, that is slope intercept form. Now see here, now if I take the rough sketch, so it is of the form dy dx. So first thing is you take vertical strip, so you are taking this complete strip. One is the equation of x square, this particular thing here, and it is 2 minus x, which I have converted into slope intercept form. Now I need to change this course to dx dy. So what I'll do is, see here, if I want to change this course, see, from this point I have two regions. This is my region 1 you can take, and this is my second region. And this time I am when I am changing this to dx dy, I am taking horizontal strip for this region 1. So let me consider this as I1 and this as I2, right? For region 1, right? So what will be my value? Okay, so see here, this is x equal to 0 to square root of y for this particular region. Sorry, yeah, see, for this region, so I am taking, that is horizontal strip, x equal to, that is 0 to, this is in terms of, I need to convert this in terms of, that is x, so it becomes x equal to square root of y, right? This, and what is happening to, that is the range y. So y is ranging from what? 0 to, that is here, till here, 0 to 1. Okay, so this first integral is over, right? Now I will take my, this is my I first part and this is my second part, right? Now the second region is x equal to 0 to, I am taking horizontal strip, so the second region will be, that is, what is happening to x? So it is 0 to this particular value, right? So it will be 2 minus y, because it is What is this equation? This is y is equal to x minus 2 minus x, so that turns out to be, here it is 2 minus y now, right? And what is the value of y, how it is y is ranging? See, and this is important. So value of y is ranging like this, 0 to, and that is 1 to 2. So first thing is you should have the idea of drawing a rough sketch, and this is my second region. And finally this part I won't explain you, right? So we need to evaluate this region 1, region 2 separately. So this is region 1, I have evaluated it, it is 1 by 6. This is my region 2 and it is 5 by 24, and final answer it is 3 by 8. Okay, so this is all about change of variable with respect to, that is, our function. So this is end of lecture 2. So in my next class I will be dealing with the concept, that is coordinate points, that is change of variables in terms of r and theta. Okay, till then you practice problems, and at any instant if you have any doubt you are free to text me up or call me up, right? Thank you very much.